Your eyes do not deceive you. This is a Wii U Gamepad with an OLED screen running Switch games on real hardware. No software gimmicks, no editing tricks, no tether. Top tier ergonomics paired with the immense Switch game library. This concept has been talked about for years, but today, it's finally here and I've been having a blast with it. But to explain why I even built this, we need to go back to the Wii U itself. An underrated, mismarketed, commercial failure of a console. I could count on one hand how many people I know that own a Wii U. The ergonomics are fantastic and the sticks and triggers feel super solid. It's a shame that the gamepad has no internal hardware to run any games locally, so you could actually take it outside of the tiny range from the console. Upon my research into if anyone has done this before, I found tons of posts and comments stating that they prefer the ergonomics of the Wii U Gamepad, but the portability of the Switch. And I'd have to agree, compared to the Switch Lite in particular, it is night and day. But I also found posts asking if it was even possible to transplant a Switch inside of the Wii U Gamepad to get the best of both worlds. One guy said this: "That feels a bit like a bat signal. I've gotta do it now." Let's start with 5 rules for the build. All buttons on the Wii U Gamepad must work, including the original thumbsticks. It has to look like a normal Wii U Gamepad. We're going for a sleeper build. It has to have real Switch hardware, no emulation or software streaming. It has to be better than a standard Switch, and it has to be durable enough to take traveling. I've ran over a few potential plans and it should be possible to get working, but there are quite a few obstacles and technical challenges that we will have to cross to get there. The problems that I'm preempting are the overall fit and SD card and charge port access, durability, thermals, and I'm sure more will surprise us. First up, the consoles. I've got a black Wii U Gamepad and a Switch Lite to jam inside of it. I chose the Switch Lite because all of the buttons are built in. This will make wiring everything up a tad more simple, especially because we don't have to power a separate controller board internally. The Switch Lite screen, including the bezel, is almost the same size as the gamepad screen. I bought this console as junk the last time I was in Japan. It says here on the box that the console powers on, but the L stick doesn't work well and it's a junk item. I mean, you be the judge of that. As for the thumbstick, all it needs is a bit of isopropyl alcohol to clean the internal contact pads. Simply lift up the rubber dust cap and spray some in, give it a wiggle, and it's like new, fully functional. I'll definitely be using everything we don't need as replacement parts down the line. So which shall we start with? Let's go Wii U. There are 10 tri-wing screws under these little squares holding the back shell in place, and 2 captive screws for the battery cover. There were 2 different battery sizes you could get for the gamepad. The smaller version came included with the console, then a larger battery could be purchased that fits horizontally. We need to detach the vibration motor cable before removing the back shell. It's been a while since I last opened one of these, but I had remembered that there's a lot of empty space in here, which is perfect. Now the Switch. I'm much more familiar with this. We've got 8 screws here, 4 Phillips on the top and bottom, and 4 tri-wing on the back. Then we can slide around the edge to pop the back shell off. This big plate likely won't fit, but I do have a plan. Pop it off and we can see the board. Maybe I'll wire up the headphone jack to the original jack on the gamepad too. It'll definitely fit inside after a lot of cutting to the back shell. The Wii U Gamepad is very modular, just like most of the consoles past this point. Nintendo's hardware design has really improved over the years, even if their thumbsticks haven't. Well, anything's better than an N64 thumbstick, I suppose. But this, in comparison with the original 3DS, is drastic. Something as likely to get damaged as a game slot shouldn't be soldered down to the board in my opinion. The heatsink and pipe should fit fine here, but I do wonder about the exhaust. It wouldn't quite follow the rules to drill a bunch of holes in the top of the gamepad. Maybe there's something else we can try. For the same reasons, I haven't got a good idea for accessing the game slot externally. The screen ribbon and the long intermediate ribbon are the two most fragile connections on this system. It's far too easy to bend a pin on the screen connector when inserting the ribbon. I've done it a few times and replacing those connectors isn't the most fun thing in the world. All of the others are quite solid. Most buttons on the console use membranes that connect these gold contacts together. It also gives us an easy place to solder to for our button connections. The tactile buttons like home, capture, plus and minus are more difficult to wire to. Some spaghetti is going to be inevitable. We're going to need this frame too. It already houses the fan and the battery, so it's better than reinventing the wheel. I think it's made of magnesium too. The screen. This is a little tricky to remove without cracking the display, so we'll try our best. I like to run a wedge along the side to separate the adhesive. You can't go too deep, or it'll rip the ribbons. Then we can pull it out. This ribbon is the one I'm most concerned with. It's definitely not long enough, but the contacts are gold, so I could solder wires to them if need be. But that's a problem for later. This screen is a tad smaller than the opening, so first I need to make a basic frame to line it up and find the best location for the components. These 3D scans of the switching gamepad can be found online. I'll have them linked below as I always find them helpful. Although, even with the frame, this corner is conflicting with the thumbstick in the gamepad. I've tried cutting an opening, but it isn't quite enough. We need to remove the shoulder button and Dremel down the corner. There are scans of the board layer by layer online, so I use these to see where is safe to sand down. There's really not a lot in this section, mostly ground planes, so we'll be fine. The frame needs to be cut more though, and look at that, it fits. This fills me with determination, but we haven't really started yet. The daughterboard will fit here even with this frame piece, but I may make a few cuts later. The first major obstacle, the thumbsticks. I'm sure it's obvious that this thumbstick is larger and different to the Switch's. I don't know if they are directly compatible, but there's only one way to find out. I've compared the pinouts of them both. It looks like it's as simple as wiring each pin to its corresponding point. It's easy to see which point each pin goes to under a microscope. I'll have the one I used linked in the description if you want one too. I've just put it back together, so let's see. Looks a bit jank. If we power it on. Yeah, I also wanted to know if we caused any damage by shaving down that edge there, but it seems like we're just fine. So this is the right thumbstick, which, yeah, looks fine. No drift, no nothing. That's quite motivating. Now, next thing to figure out is how the buttons are connected. Given that, I'm thinking they're probably the same as a Switch, meaning that they're active low. Let's see. Now that we know they're all active low, we can just look at the wires and see where each button goes. And I'll wire up one of the buttons to see if it'll actually press. But which button? Which one is the most exposed? I mean, it's probably that one. ZR. Let's do ZR. We're switching it up, and actually I'm going to install a mod chip in the Switch. I think it's best to do it now before we wire up all of the buttons so it's easier to troubleshoot if something goes wrong. First, I need to flash the Pi on the board with its firmware, as simple as drag and drop. Then we have to install the chip. This is the PicoFly mod chip based on the Raspberry Pi 2040. We access the points we need to solder to by removing this metal plate. Then we can tin them up and solder the first flex in place. These can be very tricky. It's easy to knock one off or bridge the wrong points. Done. What do you think? Next up is the flex, which connects to the inbuilt flash pins. The older versions of these flex boards were much trickier. This is a big improvement. Now I've got it back in the console, let's check that everything is connected properly. And it boots. Thumbsticks still works. Now we can test if the buttons work the same. I'm going to wire up one of the face buttons on the gamepad to ZR on the Switch. This should work as both seem to be active low. These buttons work, but what about our new button? Boom, ZR input. Surely this is going to work now.
This is definitely gonna work, as long as everything fits, and I don't break anything.
Since I don't want to wait around for custom PCBs for this build, I'm going to cut my own PCB from the gamepad board. Don't worry, it was already broken. I want the button ribbon connectors on either side, so then I can wire up all the buttons on the Switch directly to the connector, and then I can plug and unplug these buttons freely without having to worry about more wire spaghetti. And wiring them up is going to be painstaking. So before that, I'm going to update the printed frame with gaps to line up with the Switch's frame and hold it more solidly in place. Nice, but I'll probably update it again later. Welcome to probably the most difficult part of the build. Micro-soldering wires to each of these tiny pins on the connectors. It's difficult to not create any solder bridges as it's so small, as you can see. Solder wick comes in handy. It is difficult, but difficult is not impossible. It just takes time. There are a few ways you could wire these up, but this was honestly the first idea I had, so we're running with it. The other connector has a few less pins and also some wires we can scratch away to space the wires apart better. I'm using UV resin to hold each wire down. The last thing we want is to rip one of them up and damage the board. There may not be another point to solder to. Then we can connect each of our wires to their respective buttons on the Switch. I've made a text document with the pinouts of each connector if you are curious. Some of these are very small, but overall they aren't too bad. It's looking good so far. Now the daughter board needs the shoulder button removed and the buttons wired up too. Before we start finishing off, I said that this system needed to be better than original. We already have a mod chip, but I think a screen upgrade is due. This is the Super 5 OLED developed by Taki Udon at Retro Remake. It's a brand new vibrant OLED display with inky blacks for the Switch Lite. And it still has a touchscreen. I pre-ordered this a long time ago, so I'm happy to have found the perfect build for it. Another benefit is that the backlight ribbon is much longer for this screen. We're really getting close here, but I need to update the 3D printed frame once more for this upgraded screen, and also make some screw holes so nothing moves around. With it printed, we can adhere the new screen to the new frame before inserting it into the gamepad. This piece is finished. No more updates, it's perfect-ish. We can now screw in the Switch frame to the 3D printed one. I plan to take this with me the next time I travel, so it needs to be durable, as per the rules. To finish off our buttons, we need home, power, and the capture button wired up. I'm going to use the TV button on the gamepad for capture, as there is no capture button. Power and capture need to be wired up to the daughter board along with ground, and home is wired to the home button on the Switch motherboard. There are a couple test points that'll help us. We don't want the wire to rip off over time from the button presses. The power button is the last pin on this connector. I could solder it to the test point further down, but this seems more solid. With all three boards wired together, we can start assembly. I've added some tape anywhere there is metal that may create unwanted contact with the board. The button board slides in place just as before, and we can plug in the screen. Unfortunately, my spacing was a little off. There is barely enough room for this to plug in. Same goes for the LCD ribbon. After enough tribulation though, I eventually got it. I could update the frame again, but I've already drawn the line with that one. We can roll with it, if it works. The new screen has this intermediary board for power. It connects in between the battery and the Switch so that it can power the screen directly. I do wonder how this will impact battery life. Maybe a battery upgrade is due for part 2. Like the video and subscribe if you want to see that. This long backlight power cable is perfect though. It was a stroke of luck that I still had this screen on the parts shelf. With everything plugged in, we can test if the OLED screen works. Oops, forgot to plug the extra screen ribbon in. And we have display. No SD card, that's alright. Let me set one up quickly and see if it'll boot. Perfect. But I've found the problem with the thumbsticks. The horizontal axis is flipped. When I move left on the joystick, it moves right on the console. This appears to be where the most documented previous Switch U attempt halted. The thumbstick orientation is incorrect, but all of the other buttons are working perfectly. To figure out our thumbstick issue, we have to figure out how the thumbstick actually works. Both Switch and Wii U thumbsticks function the same even though the materials and shape are different. There are 2 axes for the analog movement. Each axis has a potentiometer with 3 pins, a voltage line, ground, and then the data line. When the stick is moved along these axes, it moves a wiper that slides along the pad on the potentiometer that in turn changes the resistance value on the data line. The console then reads this value from both axes to determine the direction in which you're pushing. But here the 2 thumbsticks are flipped upside down to each other, so an up input on one stick would have that same data value as down on another, even though the console interprets them as different. That means that there must be an orientation mismatch between the Switch and the gamepad. The horizontal axis needs to be inverted on the right stick. But what about the left stick? We haven't wired it up yet, so it would be easier to test with. The Switch Lite expects the left thumbstick to be upside down relative to the right thumbstick. However, on the Wii U Gamepad, the thumbsticks are mirrored, but then they could be wired differently even if they are oriented that way. I'm going to take a guess and say that the vertical axis needs to be flipped on this stick because the horizontal was flipped on the right stick, and the gamepad sticks are 2 different modules, whilst the switches are the same part. I don't know. I can always change it later. Basically, the voltage and ground pins on the problematic axis needs to be swapped around, which makes sense, it's an inversion. To do that, we first need to grind away any original connection and coat it to stop any bridges before wiring them up. Then the same thing on the right thumbstick, except flipping the horizontal axis with a couple wires. That wasn't too bad. I'm pretty confident that that will work just fine. Well, if my guess was correct. This is hopefully the last time we have to screw in the motherboard. Everything from now we can do with it installed. But before we plug in the daughter board, we need to wire up our new vertically inverted stick. The solder points on the daughter board are a little trickier than the other side, but everything's connected just fine. I'm making a few more cuts for the thumbstick wires and to give space for the boards in case everything tightens when I put the back shell on. We want to minimize boards flexing as much as possible. That's enough for a final test. And the sticks are both in the correct orientation. Sweet.
Everything works.
I'm glad I don't have to take that apart again.
So what now?
And that brings us to our next decision. The speakers. Both consoles have two main front-firing speakers. I think either would work fine, although I do like the idea of using the original speakers, retaining another original I/O. But it may sound worse than the Switch speaker, I'm not sure. Either way, I'm using the original speakers, so I'm going to cut the old connector from the speaker and solder the Switch's speaker connector instead. That way we can just plug and unplug if it needs to be taken apart again, which has some likelihood. They look good and they connect solidly. We'll see if they work after figuring out how to keep the original ports on the top. The board slides in place like this, but we only really need the top part, and the screw points are on the top section. So I'm going to cut along that gap and screw it back down in place. It's all looking very promising. I'm going to wire up the headphone jack too, since we're keeping the ports there. The headphone jack is connected to the game slot, so we need both plugged in. The pinout looks the same on closer inspection, so I'll wire them up one to one and see if it works. The wires can be tucked under here as there's extra space now. The final piece, the back shell. This is usually one of the most frustrating parts of a build, as if you mess up then there's no going back. I had forgotten there's a vibration motor in here. Unfortunately, the Switch Lite lacks HD rumble, so we can't upgrade that. That sounds like something I can look into in the future. We also have to remove the stylus to avoid damaging any of the wires. I'll glue in just the end so it looks like it's still inserted in the console. It won't work on the Switch's screen anyway. The main part needing cut is this battery cradle in the center. With that gone, most of it will fit. Then we just need to worry about anything else catching on the posts in the shell. Looks good. What about ventilation? I was wondering where to put the exhaust vent. There are two holes on the back of the gamepad that connect to this piece. If I remove these two covers, then air should be able to escape out the back whilst being sucked in from the bottom. It's not quite optimal, but I'll see how it tests and go from there. I could 3D print a shroud to direct the air better. This is the last point of failure that I can think of. We can either cut a big hole and 3D print a cover so we can access this SD card slot, or we can epoxy a new slot in the back shell and wire it up manually. I'm liking the latter. I think it adheres to the rules better. I also have a 3DS SD slot we can use. Although, upon testing I found that there was too much interference with this magnet wire I used. I eventually had to replace them all with this sheathed wire instead, which improved the speed and reliability drastically. Doing this once was headache enough, but I did it twice due to my own stupidity. It may have been easier to just cut a hole in the shell. It would be more reliable too. But eventually I got everything wired up and solidified. It's time to complete the final assembly. This new smaller plate came with the OLED screen. It avoids touching any of the new cables. After plugging in the last few cables, we need to screw the last 10 screws in and attach the battery cover, which still holds in place, because I avoided cutting around the screw posts. I've also set up a 512GB microSD card for it with a custom background. I think I'm going to play this a lot. I can finally peel off the protective film and apply the included screen protector. Well, that looked cool. This turned out amazing. I think it looks barely modified and definitely fits within what I would call a sleeper build. The printed frame and larger bezels aren't too noticeable, and I think it would trick most people, if they even know what a Wii U is in the first place. Literally every button on the gamepad corresponds to a button on the Switch. Everything is mapped one-to-one other than the TV button, which is capture, and I've also wired up the sync button on the back for volume down. I have a couple ideas on what to do for volume up later, but for now if I need it, it's just behind the battery cover. The sticks are calibrated perfectly and it all feels solid in the hands, even if the charge port is a little tricky to plug in. But now I'm intrigued with game load times with the new SD slot, thermals, and to see if we can get some emulators running. This screen looks incredible. It's a massive upgrade over the original. It's a shame that they are out of stock. They are developing other devices at the moment, so I'm not sure when these will come back. Everything I've played runs perfect. We don't need the game slot as digital titles can be installed, and now we can also install emulators to run retro games. Everything looks amazing on this OLED screen, although the temperature is around 5 degrees higher than stock, so I will look into that later, but it's not the end of the world for now. The new screen controller chip is probably contributing to that too. But hey, 5,000 likes and I'll do a part 2. After figuring out a few additions like game slot access, better ventilation, making the original slider work, and if you've got any more ideas, let me know in the comments. All in all, mission success. This is definitely coming with me the next time I'm on a plane. That is, if it would even get past security.